Really quick, I would note that I have tan cubed on top. We don't want tan cubed. That's none of our identities. So we got to figure out a way to get rid of it. And the easiest way in this one is to notice that there's tangent in all the parts of the numerator. So you're going to pull out a tangent out front, which is going to give me tan x times tangent squared x minus secant squared x all over. And that negative sign, if it's cotangent, you bring the negative out front. So it'd be negative cotangent x. Well, really quick, I would notice that we have tangent squared and secant squared together. So we're probably doing something with that 1 plus tangent squared x equals, secant squared x. Well, in order for this to be tangent squared minus secant squared, you need to subtract secant from both sides. So that means you would have a negative secant over here, which means I need to move the 1 to this side, so that would be a negative 1. So this right here all equals a negative 1. Well, that's going to give me negative 10x over negative cotangent x, which will turn to a positive. So we'll have tangent x over 1 over tangent x. Well, this is keep, change, flip, so it'd be tangent x times tangent x over 1, which is just going to equal tangent squared x. All right, what questions do we have from our homework? What was that? 6.2a. Oh, it's factoring one. Chris. All right, for number 35, 35 has sine squared times cosine b plus sine b cosine b minus 2 cosine b. Know how to do this one, because this one's kind of a weird one. So we have sine squared beta cosine beta plus sine beta cosine beta minus 2 cosine beta. What you need to start recognizing is when something is every single element along the way. In this case, we have cosine, cosine, cosine. We have the same element in all three of the things, which means before I even start this problem, I need to factor out that cosine out front. So I'm going to factor out that cosine from all three of those places, which is going to equal cosine beta times sine squared beta plus sine beta minus 2. Now we'll see it's sine squared plus sine minus 2. That's just like x squared plus x minus 2. So this is something I can factor. Well, to give me sine squared, I need sine beta in both of our front terms, and then I need to equal 2 at the end, and that's negative 2. The only way that works is negative 2 is a 2 and a 1. Then you just have to make sure your middle term is positive, so it's going to be plus 2 minus 1. So before you can even do this problem, you had to factor out that you had to recognize that you had to pull a cosine out of all three of them. Otherwise, it's impossible to come up with a binomial times a binomial. It just won't work until you factor out that cosine. Other questions? Leo.
For 11, shouldn't it be like a squared minus b squared?
Number 11. Did we do a number 11? Oh, I see. It says find the product. And it won't be a squared minus b squared, because notice it says 2 cosine beta plus 1 times cosine beta minus 1. Your a values aren't the same. There's that 2 up front, so you'd have to actually factor it. Or distribute it, I should say. Do you see the difference?
Yeah.
It would have to be cosine beta plus 1, cosine beta minus 1. Or it needed to be 2 cosine beta plus 1 and 2 cosine beta minus 1. Then you can do the a squared minus b squared, but it has to be exactly the same. Otherwise, that middle doesn't cancel out. All right, other questions? Brody? 9. All right, number 9 says we were supposed to simplify cosecant x divided by sine x. Well, that's cosecant x divided by 1 over sine x. I'm sorry.
No, it's 1.
Hang on. I'm going backwards in my life. All right, it's 1 over sine x all over sine x, correct?
Yeah.
All right, to do that multiplication,
Oh, I see.
you're going to keep change flip, which would be 1 over sine x.
Mm-hmm.
Well, remember your denominator is actually sine x over 1, so it'd be 1 over sine x, which equals 1 over sine x squared, which is going to be cosecant squared x. Other questions?
Wait, G says it's 1 plus cosine squared x.
Mm-hmm. That's the same thing as cosecant squared x.
Oh. Well.
It's one of your Pythagorean identities that says cosecant squared x equals 1 plus cotangent squared x.
Would it be wrong to do after that cosine squared x?
It would be wrong if you were given A, B, C, D, E, F, G, H, I, J, and you had to pick one.
Yeah, like,
But on a test, if I just had that, the correct answer would be cosecant squared x, because that is the most simplified form. So these weren't necessarily simplifying, they were to match up with what we had on the side.
Right.
Other questions? Going once. All right, today we're going to start working on actually verifying identities that will actually be part of your homework. With verifying identities, let's go over this once again. You choose which side of the equation to start with. Usually you pick the most complicated of the expressions, because like I said, it's much easier to tear something down to build it up. Simplify the side until it reduces to the other side. Sometimes it won't reduce all the way, and you have to go back and start working on the other side. Write expressions in terms of sines and cosines. This is just a tip. If nothing's working, write it in terms of sine and cosine. You won't always need to do that, but that is a good key. If you're stuck, write things in terms of sine and cosine. Multiply the numerator and denominator of one expression by the numerator or denominator of the other. That was when we talked about pushing them together, pushing our fractions together so they have a common denominator. If the numerator of the rational expression is a sum, you can write it as 2 rational expressions. So if you have this, nope, I don't have the addition in the denominator. We can rewrite sine of x plus cosine x as sine of x over sine of x plus cosine of x over sine of x. So there are times where we split apart fractions. There are times where we push fractions together, and there's times where we split it apart. You just don't know until you try doing these problems. A big mistake I saw people do on the test last year is if they had the sine x plus cosine x in the denominator, they split it apart. Doesn't work that way. It only works if it's in the numerator like this. Has to be in the numerator to split it apart. All right, combine the sum or difference of 2 rational expressions into one rational expression. And another idea is work with both sides independently. The result should be an obvious identity. Quick reminder. There's no working on both sides at the same time. You cannot multiply both sides by 2. You cannot subtract sine from both sides. You can't add sine to both sides. You build a wall and you work independently on either side. Nothing can cross between the 2 sides. All right, so our first one, and one that just pops up a lot. is using the conjugate. That's why we did it on Friday, and we're going to do it again today. If you ever see like 1 plus sine x and 1 minus sine x, or any variation with any other trig function, so 1 plus cosecant, 1 plus cosine or something, it's always a good sign that you might have to use the conjugate. So it's a good idea to at least try the conjugate and see if it helps you. Well, on either side of this equation, we have 1 minus sine theta and 1 plus sine theta, so we can multiply by the conjugate on either side. I'm going to pick the left side. Not that it's any more difficult, they're both the same, but I'm just going to pick the left side. So I'm going to build that kind of wall up between the two to remind me that I only can work on one side at a time. I'm going to multiply the left-hand side by the conjugate. The conjugate of 1 minus sine theta is 1 plus sine theta. So I need to multiply the top and bottom of that fraction by 1 plus sine theta. So that's exactly what I'm going to do. We have cosine theta all over 1 minus sine theta. But I'm going to multiply the top and bottom by 1 plus sine theta over 1 plus sine theta. Once again, I'm multiplying by 1, so it's okay. Most of the time, not every time, we might not even need to distribute this cosine, so I'm going to wait to see if I even need to distribute it. So I'm going to leave that on the outside. I'm not going to distribute it. I'm just going to write this as cosine theta times 1 plus sine theta on top. And the reason why I'm leaving that, this is a minus b times a plus b, which is going to give me 1 minus sine squared theta. Well, if I'm thinking far enough ahead, 1 minus sine squared theta actually equals cosine theta. It comes from that sine squared plus cosine squared equals 1. So the whole idea of multiplying by the conjugate is to turn this 1 minus sine theta into cosine. And if we're thinking far enough ahead, why don't I just leave that cosine on the outside, because we know stuff's going to cancel out. So our next step is we're going to have cosine theta is 1 plus sine theta all over cosine squared theta. Well, our cosine and our cosine squared will cancel out. So my cosine's completely canceled out, and it will no longer be cosine squared theta. It'll just be cosine theta. It's just like x over x squared. It turns into 1 over x. So this is just going to be 1 plus sine theta all over cosine theta, which I am done because the other side's already that way. All right, so that's multiplying by the conjugate. Always a good idea to try it if it's ever 1 plus or 1 minus something, because you want to turn it into something that's on our identity sheet, which are those squares. All right, so that's using our conjugate. Our next one. Obviously, that left-hand side is the most complicated of the two, so I'm going to focus on the left-hand side. In this one, we're actually going to solve it 2 different ways. I'm going to solve it one way here, and we're going to do another way over here. In this case, it works both ways. Some problems won't work both ways. All right, so I'm going to see I have that cosecant x minus sine x all over sine x. This is a perfect problem to break it apart into 2 fractions, because I can break this apart into cosecant x over sine x minus sine x over sine x. And I like that because then I'll have just a 1 in there. So I'm going to break apart that fraction. I'm going to break apart that fraction into cosecant x over sine x minus sine x over sine x. here's kind of something we need to start recognizing. That cosecant x over sine x. Cosecant x over sine x is 1 over sine x divided by sine x. What note did I actually put there? I did put a note, so I started skipping it. So that is 1 over sine over sine. Well, that's the same thing as 1 over sine times 1 over sine. So our cosecant over sine x is just going to be 1 over sine squared x. Minus 1. Well, 1 over sine squared x is really just cosecant squared x minus 1. Well, anytime I have a cosecant squared, I look at my identity sheet, or I have it memorized, or on a test, what's probably a really good idea is as soon as you get the test, write out those Pythagorean identities. Just then they're there. And then you don't mess it up and you forget about it. All right, so if you look at your handy-dandy sheet, or if you have this memorized, look at the one that has cosecant on it. Well, we have 1 plus tangent squared. We have 1 plus cotangent squared equals cosecant squared. In order for it to work, you have to subtract the 1 from both sides, which would give you that cotangent squared equals cosecant squared minus 1. So we are, in fact, done. We have cotangent squared equals cotangent squared x. We're going to do another method on here too. Here's another method. See, you have cosecant and sine. There's one thing different. It's cosecant. Everything else is sine. So rewrite cosecant in terms of sine in your first step. So my other method is to rewrite that cosecant as just 1 over sine x minus sine x over sine x. Now what I'm going to do is I'm going to get rid of the fraction that's on top. The way I'm going to get rid of the fraction on top is I'm going to multiply the entire top by sine of x. Because if I distribute the sine of x, I'll have 1 minus sine squared. I'll get rid of that fraction. I'm not allowed to just multiply sine x on top willy-nilly. What we need to do is we need to multiply it by sine x over sine x, so I'm multiplying by 1. Now that's going to get distributed to both things. This sine x is going to go to that one. And we are going to have sine x divided by sine x is just 1 minus sine squared x over sine squared x. Well, 1 minus sine squared is just cosine squared over sine squared x, which equals cotangent squared x. This is a good trick to know. This is a good trick to know, multiplying the numerator and denominator by something to clear out a fraction. And I believe there's one in your homework too that I think you have to do this in. There's one where breaking apart doesn't really work, that you have to do this multiplying the top and bottom to clear out a fraction. Questions on either method? Okay. Yeah. Oh, sorry, Bertie. You're too close to me.
Are we gonna know if like the second method works in like?
You don't.
So also like we have to try out one of them, and if it doesn't work.
If it doesn't work, try out. It's all about, it's like a puzzle, right?
Okay.
See if that piece fits. If it doesn't, try something else. A good sign that you have to use this method, Brody, is if you have, maybe it's flipped. Maybe I have cosecant minus sine in the denominator and I can't break it apart. That might be a good time to try clearing out the fraction that way.
Okay.
All right, so if you can't break it apart, or when you break it apart, it turns into this very confusing mess. then go back. So these are kind of good to take a second. Think about what would happen if I did that step. If it looks like it's really messed up, think about another way I could do it. Yeah, a lot of this is kind of trial and error. And the more time you do these problems, the more you can kind of pick out what you should do where, and it makes it a lot easier. All right, 2 methods, same problem. All right, our next one is we need to verify the identity 2 tangent squared x equals all of that. So the more complicated of the two sides must be that right side, so I'm going to pick that one. But I'm not going to draw straight down because I'm going to notice we have all this space and a lot going on, so I'm going to draw kind of a janky line right there. All right, where 2 tan squared x is on that side. Because I know I have to do a lot of stuff over here. I have 2 fractions. When I have 2 fractions, your general idea is push them together. Push those 2 fractions together. In order to push them together, they have to have a common denominator, which means multiply either fraction by the other's denominator. So we're going to take this 1 over cosecant minus 1. And we're going to multiply it by the other denominator. So that's going to be times cosecant x plus 1 over cosecant x plus 1. That'll be minus. We'll take the other one, which is 1 over cosecant x plus 1, and multiply that one by the other denominator, which is cosecant x minus 1, cosecant x minus 1. All right, we got time. All right, let us distribute all this. So I have 1 times cosecant x plus 1. So we're going to have cosecant x plus 1 all over, and that's a difference of squares, so it's going to be cosecant squared x minus 1 squared, which is just 1, minus cosecant x, here's the rub. Well, we'll just leave it as is for now. So we have cosecant minus x all over, or cosecant x minus 1 all over cosecant squared x minus 1. Can someone tell me what cosecant squared minus 1 equals? What can I replace that with? Real quick. So cosecant squared x minus 1 equals. Brian? Cotangent squared x. So that just equals cotangent squared x. So our denominator is going to be cotangent squared x. If you were not near knowing how to do that, you should practice doing that stuff. All right, so on our numerator, we're going to push everything together. So we are going to have cosecant x plus 1. Here's where people are going to miss points. There's a negative out front. That negative gets distributed to everything in the numerator. So that negative is going to go there. That negative is going to go there. So we're going to have minus cosecant x plus 1 all over cotangent squared x. Well, that's cosecant minus cosecant, so those will cancel out. We'll be left with 2 over cotangent squared x, which is the same thing as 2 times 1 over cotangent squared x, which just equals 2 times tangent squared x. Which is exactly what we had here. So your big step here was just pushing 2 fractions together. And realistically, these problems are just one big step and a bunch of little steps. All right, any questions on that one? Okay, let's go to the last one. I don't even have the last one up here. Let's see if I have the last one as a slide. All right, this one we have some negative signs in it. So we're going to build our wall up. And I'm going to get rid of the negatives on both of them. All right, it's always a good idea to at least get rid of the negatives on both sides. So work on them independently and get rid of the negative signs on both, and then go from there. So our left side, we have 1 minus sine squared t all over. With cosecant, you pull out the negative sign, so it'll be 1 plus cosecant t. Same thing with sine. You pull out the negative sign. So we're going to have 1 minus sine t, I should say, all over cosecant t. Well, you might look at that, you might decide to start on the left-hand side. We're not going to, but I just want to forward think. 1 minus sine squared t is cosine squared t. But then I have cosine squared t all over 1 plus cosecant. I could turn cosecant into 1 over sine, but you can kind of see you kind of get stuck here trying to get it over here. So instead of doing that, what I want to look for is turning this into a square. Because we notice there's a sine squared up here. I want to turn this into a sine squared. Well, another thing that will jump out at us is anytime we have 1 minus sine, 1 minus cosine, 1 plus sine, 1 minus cosine, something like that, multiply by the conjugate. It's a very easy way to get squareds on top, knowing that I have a sine squared on the other one. So this right here is a good use of our conjugate. So we're just going to multiply the top and bottom by the conjugate, where our conjugate is 1 plus sine t over 1 plus sine t. Well, 1 minus sine t times 1 plus sine t gives me 1 squared minus sine squared, or in other words, 1 minus sine squared all over. Now, this is one of those weird times where you actually distribute the cosecant, because the cosecant is not going to cancel out here. So we're going to actually distribute it. So we're going to have cosecant. Maybe we'll draw the picture, so we're distributing it to both. So that's going to give me cosecant t plus cosecant times sine. But cosecant and sine are just reciprocals of each other. They should undo what the other one does. In other words, think about that as being 1 over sine times sine over 1. Well, that's just going to equal 1. So we now have 1 minus sine squared t all over cosecant t plus 1. Well, that is the same thing here. They're both the same thing. 1 plus cosecant is the exact same thing as cosecant plus 1. So we are, in fact, done. You can either rewrite it to match it, or you can just leave it as is. I'm going to rewrite it to match it. And that's it. All right, questions? All right, then go ahead and get started on the homework. Make sure you're checking the answer key.